Welcome to our segment on nebula. We'll be seeing some amazing scenes from across our galaxy. In recent segments, we've seen two types of nebula. Both have been connected with stars dying. Planetary nebulas such as NGC 2371 are all about normal stars at the end of their hydrogen-burning life. And supernova remnants, such as SNR 0509, are the remains of giant star explosions at the end of their fusion factory life. But the most beautiful nebula come from vast molecular hydrogen clouds where new stars are being born. To understand these areas a bit better, we need to know a little more about nebula. There are three basic kinds: reflection nebula, emission nebula, and dark nebula. Reflection nebula are clouds of interstellar dust grains that are reflecting light from a nearby star. This Witch Head Nebula is an example. It is reflecting light from the nearby star Rigel. In this photograph, the blue color of the Witch Head Nebula is caused by the dust grains scattering blue light. The same physical process causes Earth's daytime sky to appear blue. Emission nebula are shining their own light. In order to do that, the gas and dust need to be excited to the point of luminescing. This is accomplished in two primary ways. One, by exploding stars at the end of their lives, like the two we just saw, and two, by new stars exciting the clouds they are born in. The Rosetta Nebula is a good example of this. This nebula is a vast cloud of dust and gas extending over an area almost 100 light-years wide. It would cover our entire solar neighborhood. As parts of a great molecular cloud condense, new stars are created. These hot new stars shine brightly in the ultraviolet. This is exactly the right wavelength for radiation to ionize hydrogen molecules and atoms by stripping away their electrons. This sets off a series of quantum effects that create photons in very large numbers, creating the light that we see with our telescopes. You can see the young, recently formed stars situated within this nebula. They formed from the nebula's material, and they are the stars that make the nebula shine. Areas like the one creating the Rosetta stars are called H2 regions. There are only a few thousand of these in the Milky Way because they only last a few million years. Radiation pressure from the hot young stars drives most of the gas away. The Pleiades are an example of a cluster which has boiled away most of the H2 region from which it formed. Only a trace of blue reflection luminosity remains. Our third kind of nebula, dark nebula, are not shining at all. They are clouds of dust and gas that are positioned in front of bright nebula obstructing its view. The Horsehead Nebula is an excellent example of this. Rising from a sea of dust and gas like a giant horsehead, the nebula is one of the most photographed objects in the sky. It is a cold, dark cloud of gas and dust, silhouetted against the bright nebula. The most interesting nebulae in the Milky Way are made up of all three types: emission, reflection, and dark. So let's take a look at some of these scattered across our galaxy. The cloud surrounding the star system Rho Ophiuchi, or Rho Oph for short, is one of our closest star-forming regions. Rho Oph itself is a binary star system visible in the light-colored region on the right side of the image. The star system is distinguished by its colorful surroundings, which include a red emission nebula and numerous light and dark brown dust lanes around 5 light-years wide. Near the image bottom lies the Blue Horsehead Nebula. The blue glow that surrounds the Blue Horsehead's eye is a reflection nebula. You can't see the stars behind the clouds in visible light, but X-ray and infrared brings them into view. The bright pink objects are young stellar objects. These baby stars are just now forming. Many of them are still enveloped in their own tiny compact cloud called their baby blanket. There are more than 300 young stellar objects within the large central cloud. Their median age is only 300,000 years. And that's very young compared to some of the universe's oldest stars, which are 12 to 13 billion years old. This spectacular wide-field image shows the area around the star R Coronae Australis. A huge dust cloud, about 8 light-years long, dominates the center of the image. At its tip in the upper right is a group of lovely reflection nebula. It is the smaller yellowish nebula that surrounds the young variable star. This is a very detailed image of the dramatic effects of very young stars on the dust and gas from which they were born. The baby stars are invisible in this picture, being hidden behind dust clouds at the upper left of the picture. But the material they are ejecting is crashing into the surroundings at speeds that can reach 500,000 miles per hour. These shock waves cause the gas to shine and create the strangely colored glowing arcs and blobs known as Herbig Haro, or HH objects. Four light-years across, this close-up of an area in the northwest region of the large Iris Nebula seems to be clogged with cosmic dust. With bright light from the nearby star illuminating it from above, the dust resembles thick mounds of billowing cotton. It's actually made up of tiny particles of solid matter, with sizes from 10 to 100 times smaller than a grain of dust we'd find here in our homes. This is the giant Orion Molecular Cloud complex. The image covers an area with objects that span about 75 light-years. It holds a number of beautiful and well-known nebula, including, of course, the Orion Nebula itself in the upper right. The brightest 3 stars on the left are the 3 stars that make up Orion's belt. The top star is Minitaka, about 900 light-years away. The middle star is Alnilam. It is a blue-white supergiant around 1,300 light-years away. The lowest star is Alnitak. It is only 700 light-years away. So you can see that these 3 stars are in line with the Orion cloud, but not a part of it. Below Alnitak is the Flame Nebula, an Emission Nebula in filaments of dark brown dust. Just to the right of Alnitak is the famous Horsehead Nebula. Moving over and up to the Orion Nebula, we also see the Running Man Nebula just to the left of Orion. This Hubble mosaic of the Orion Nebula covers 24 light-years across and reveals numerous features that reside within this nearby, intense star-forming region. More than 3,000 stars of various sizes appear in the image. The Trapezian open star cluster contains hundreds of brand new stars. The first of these Trapezian stars were discovered by Galileo. They got their name because the first stars looked like a trapezoid. As we scan the outer edges of the nebula, you can see the illuminated walls of the Orion cavern, along with beautiful elongated jets created by nearby stars being born. This is one of my personal favorites. It's the bipolar star-forming region called Sharpless 2-106. It appears in a relatively isolated region of the Milky Way galaxy and measures several light-years in length. A massive young star, called Infrared Source 4, is responsible for the furious activity we see in the nebula. Twin lobes of superhot gas, glowing blue in this image, stretch outward from the central star. A ring of dust and gas orbiting the star acts like a belt, cinching the expanding nebula into an hourglass shape. Hubble's sharp resolution reveals ripples and ridges in the gas as it interacts with the cooler interstellar medium. The dusty red veins that surround the blue emission are also illuminated by the central star. This pillar of gas and dust is called the Cone Nebula. We're looking at the upper 2.5 light years of the pillar. The entire nebula is 7 light years long. Radiation from hot young stars located above the top of the image have slowly eroded the nebula over millions of years. Swirling dust clouds and bright newborn stars dominate the view of this image of the Lagoon Nebula. Within these clouds of dust and gas, a new generation of stars is forming. This Hubble image reveals a pair of 1/2 light-year long interstellar twisters, eerie funnels and twisted rope structures in the heart of the Lagoon Nebula. Analogous to Earth tornadoes, the large difference in temperature between the hot surface and cold interior of the clouds, combined with the pressure of starlight, produce strong horizontal shear to twist the clouds into their tornado-like appearance. 3 huge intersecting dark lanes of interstellar dust mark the Trifid Nebula, one of the most recognizable and striking star-birth regions in the night sky. The dust, silhouetted against glowing gas and illuminated by starlight, cradles the bright stars at the heart of the nebula. This image from Hubble offers a close-up view of the center of the Trifid Nebula, near the intersection of the dust clouds, where a group of recently formed massive bright stars is easily visible. The Cat's Paw Nebula is a vast 50 light-year across region of star formation. It is one of the most active nurseries of massive stars in our galaxy. The nebula conceals freshly minted brilliant blue stars, each nearly 10 times the mass of our Sun and born in the last few million years. The region is also home to many baby stars that are buried deep in the dust, making them difficult to study. In total, the Cat's Paw Nebula could contain several tens of thousands of stars. This is an image of the center of the Omega Nebula, sometimes referred to as the Swan Nebula, a hotbed of newly born stars wrapped in colorful blankets of glowing gas and cradled in an enormous cold, dark hydrogen cloud 15 light-years in diameter. The region of the nebula shown in the photograph is about 3,500 times wider than our solar system. The Eagle Nebula is 20 light-years wide. Inside the Eagle there are a number of spectacular formations. These eerie, dark pillar-like structures are columns of cool interstellar hydrogen gas and dust that are also incubators for new stars. In some ways, these pillars are akin to buttes in the desert, where dense rock has protected a region from erosion, while the surrounding landscape has been worn away over millennia. In this celestial case, it is especially dense clouds of molecular hydrogen gas and dust that have survived longer than their surroundings in the face of a flood of ultraviolet light from hot, massive new stars. As the pillars themselves are slowly eroded away by the ultraviolet light, small globules of even denser gas buried within the pillars are uncovered. These globules have been dubbed EGGS, EGGS. EGGS is an acronym for Evaporating Gaseous Globules. But it is also a word that describes what these objects are, because forming inside at least some of the eggs are embryonic stars. Eventually, the stars themselves emerge from the eggs, and the eggs themselves are evaporated. This soaring tower is 9.5 light-years, or about 57 trillion miles high. The bumps and fingers of material in the center of the tower are examples of eggs. These regions may look small, but each one is roughly the size of our solar system. Here, we are zooming into the giant Carina Nebula. It is a very large, bright nebula that surrounds several clusters of stars. The nebula itself measures some 260 light-years across. That's about 7 times the size of the Orion Nebula. Let's take a look at some of the amazing structures contained in Carina. NGC 3324 is located at the northwest corner. The glowing nebula has been carved out by intense ultraviolet radiation and stellar winds from several hot young stars. The image also reveals dramatic dark towers of cool gas and dust that rise above the glowing wall. This image from Hubble shows the tip of a 3 light-year-long pillar, bathed in the glow of light from hot massive stars off the top of the image. Scorching radiation and fast stellar winds are sculpting the pillar and causing new stars to form within it. Although the stars themselves are invisible, one of them is providing evidence of its existence. Thin jets of material can be seen traveling to the left and to the right of a dark notch in the center of the pillar. Astronomers estimate that the jets are moving at a speed of up to 850,000 miles per hour. These 1 light-year pillars of cold hydrogen and dust are created by violent stellar winds and powerful radiation from massive stars. Here's a 3 light-year tall pillar of gas and dust that is being eaten away by the brilliant light from nearby stars. The pillar is also being assaulted from within, as infant stars, buried inside, fire off jets of gas that can be seen streaming from the towering peaks. Here's the Heart and Soul Nebula. The Heart Nebula's intense red output and its configuration are driven by the radiation emanating from a small group of stars near the nebula's center. Soul Nebula is the eastern neighbor of the Heart Nebula. Like the familiar Orion Nebula, NGC 2467 is a huge cloud of gas, mostly hydrogen, that serves as an incubator for new stars. The huge clouds of gas and dust are sprinkled with bright blue hot young stars. Here we're zooming into NGC 3603, a starburst region, a cosmic factory where stars form frantically from the nebula's extended clouds of gas and dust. Ultraviolet radiation and violent stellar winds have blown out an enormous cavity in the gas and dust enveloping the cluster, providing an unobstructed view of the cluster. Like globular star clusters, H2 regions come in a wide variety of sizes and luminosities. But just like with globular clusters, observations have shown that the brightest H2 regions all have a common luminosity. This makes them an important standard candle, because just like the brightest globular clusters, they are bright enough to be seen out to great distances. So we can add them to our distance ladder.